So today we're going to talk about caches. And caches are one of the more exciting parts about computer architecture because there's so much you can do with them. And even today, a lot of research focuses on how to make better caches. So the goal of dealing with caches here is figuring out how can we build a memory hierarchy that's fast. So we want to provide memory that's both fast and big. Remember, we talked about how this was a problem before. We have main memory that's big but it's slow, and we have register files that are fast but they're slow. The memory hierarchy is how we can put these together to make it look fast and big most of the time. We're going to do that by combining the fast SRAM from register files with the slow DRAM from main memory and our super slow hard disk in case we run out of space. Then I'm going to talk about what caching is. And this is going to be using a small fast memory to store important data. And the basic idea is if we find the data in that small memory most of the time, then most of the time it seems fast. Talk about how a cache works. We'll talk about using tags, that is pieces of information that let us know what's in the cache, and blocks, that is putting pieces of data together so that we have fewer tags to make a practical cache. Talk about the three types of caches that we typically have: fully associative, set associative, and direct map. And we'll talk about how we decide what to replace in the cache and how the cache works when we write data. Finally, since all of this is about making things both big and fast, we're going to talk about cache performance and how the caches that we design influence the performance of our programs.